All right, we already saw one example of a loop in Arduino, one that was in fact necessary in the Arduino sketch, the loop function. So let's say my robot is standing there doing the dishes and I hit the big red button. It's supposed to stop doing the dishes, run around in a circle 3 times, screaming, "Ah, he hit the big red button," and then maybe have it breathe fire a couple of times. We have a problem. How can I get it to perform a loop only a certain number of times? Now, if we put it in the loop function, then we wind up with our robot continually running around in a circle screaming, "Ah, he hit the big red button," and breathing fire. The dishes will never get done, because Lord knows I sure ain't going to do them. Never fear, Arduino has you covered. There are multiple types of loops which you may recognize as similar to other programming languages if you've had any experience in programming other languages. The first one is the while loop. It's the word while. Notice there is no capital letter. Make sure that text turns that khaki color, indicating that it's recognized the instruction, followed by a condition to check in brackets, and then some of the curly braces, which contains all the instructions you wish to run while the condition being checked has been met or found true. Note also, the only thing that can be outside of a function is the declaration of variables. So make sure this instruction is within a function, like the loop function or the setup function. Now, how this works is that when it encounters the while loop, it will perform everything within the curly braces as long as that condition is true. It will continually loop within this loop while the condition is true. The moment that condition is not met, it then skips over the curly braces and continues on with the program running whatever code comes after the curly braces. So open up a bare minimum sketch and let's make use of our newly discovered internal pull-up pins and write a while loop. Let's set up pin 2 as an input pull-up, and we'll also set up a serial connection so we can use the serial monitor as an indicator of what's going down. We'll then slap our while loop in the setup function. This way we know it only reads this loop once. We'll read digital input 2, and as long as it's being held high by that pull-up resistor, it writes a serial line print saying something indicating that we are in fact looping within the while loop. Then after the while function, everything that happens is when pin 2 has gone low, and thus our condition is not met. So it will skip over this function and go down here. What do we want it to do? We'll just do a quick line print to the serial monitor indicating that we are now outside of the while loop. So you can just put a wire from pin 2 and use it as a switch by connecting pin 2 to any of the ground connections, pulling that input down, or if you so wish, you can put a push button between pin 2 and ground. Now, something I failed to mention previously, I apologize. You can set up the serial monitor the way I showed you earlier through the menus. However, this button up here is a quick button. Click on it to bring up the serial monitor. So upload your sketch and then open up the serial monitor and you will see it looping there. You'll see it sitting there, looping continuously within the while loop. We did not write our code in the loop function. We wrote it in the setup function. So we did this so we know that it's only reading that loop and running it once. So this is actually looping within the while loop itself. Now the instant I connect pin 2 to ground, thus pulling down the input, it jumps out of the while loop. We then see our message indicating that it has left the loop. And it only does this once because we wrote our code in the setup function, so it only runs the code once. Another form of the while loop is the do while instruction, written as do, then the curly braces, with all the instructions you want it to do, then while, and the condition. The difference here being it will first do whatever you want done in the curly braces at least once. It will then check the condition, and if the condition is met, it'll do the work in the curly braces again. It will, of course, keep doing this while the conditions are met. So the main difference here is that it will run whatever instructions are in the curly braces at least once right off the bat, regardless of whether or not the conditions were met. It will then check the condition, and if the condition was not met, it would leave the loop. If the condition is met, then it will jump up again and to do and continue to do the loop until the condition is not met. Notice the semicolon after the while line. This is outside of and after the curly braces, so we need to indicate the end of the line. The next loop is the for loop. Now, this is a favorite of mine because this harkens back to my basic programming days when I was like 12. So I reminisce about the days when I programmed video games on my VIC-20. Those were the days. The for loop is very powerful in that it keeps a count, and you can use that count in the instructions you program. But the count is kept in a variable. So this is where it gets really powerful because you can modify the count in any way you like, perform math, both with and on the variable itself. You can get it to count up, count down, count in steps of 3, etc. So it works like this. The word for, and then in brackets, the initialization, then a semicolon, the condition indicating when you want to end the loop, another semicolon, and finally, how you want to get to that condition. Then in the curly braces, you put the instructions you want it to perform while it's counting. I want you to see how powerful this loop can be, so we'll use a pulse width modulated output to drive an LED. Let's use pin 3. Jump some wires out from pin 3 and ground to your breadboard and wire an LED and resistor in series. We'll keep the wire or push button on pin 2 and continue to use that as a way to provide input to your program. So go ahead and delete the while function from within your setup and set up pin 3 for PWM. We will program 2 for loops, and we'll do it in the loop function, so it continually runs them. What we'll do is set up 2 different for loops. The first one increasing the PWM output until it hits maximum, and thus increasing the brightness of the LED until maximum. It will then leave that loop and go to the next for loop, which decreases the brightness of the LED until it is completely off. It will then leave that for loop and loop within the loop function back to the first for loop. So let's do that first, setting up your program like this. The word for, then we set up our variable, which our variable of the day is bright in all lowercase, and we start the count at 0. That is the count for the for loop. We'll keep running the for loop as long as the variable bright is less than 256. That is until the variable hits a count of 255. We are going to count up by adding a 1 to the variable each time the loop runs. Within the curly braces, Within the curly braces, we simply make use of that same variable and analog write that variable to pin 3, the pin which drives the LED we set up. We throw in a very brief delay. Otherwise, the LED will just look like it's pulsing because the count up is so fast. If you're like me and you have some basic programming history, normally you would expect the word next, which would increment the count. But in C programming, that is actually the closing curly brace which does that. That is the indicator to loop back to the for instruction. So as long as the condition is met, in this case our count is still less than 256, then it will increment the count by 1 and loop back to the for instruction. We then write our second for loop like this. So several things I want you to notice here. We started our count at a completely different number. We started counting at 255. We count down. That's what the two subtraction symbols are for. It will subtract 1 every time it goes through the for loop. It will keep subtracting 1 as long as the variable is greater than or equal to 0. Once it hits 0, it will then leave the loop just like before. We analog write the variable to pin 3, wait a split second, then go back to the for. Go ahead and write this out and flash your Arduino with it and check that it's working. You should have an LED that takes about 3 seconds or so to increase to max brightness, then another 3 seconds or so to get to minimum brightness. Let's now monkey with the for settings so you can see everything in action. Now we've got a decent delay going on, but I want to put the delay even slower because we're going to move in large steps that are visible to your naked eye. If your eyes have any clothing on, take off those clothes. We need your eyes naked. Okay, it was a bad pun. Sorry, let's carry on as if we were normal. What we're going to do is increase the delay to a full half a second or more. You can set it to whatever you'd like, but something long so you can see the changes taking place. Instead of adding 1 every time it loops to 4, we're going to increase or decrease it by 51. Now I got that number by simply taking the maximum number of 255 and I divided it by 5, so we have 5 equal steps in the brightness that we'll be able to see. Go ahead and flash your Arduino. And hopefully this will show up well on camera. The PWM might mess up the camera because it will be adjusting the iris on the camera. So what you're seeing is the for loop stepping through the count in steps of 51. Now you can change that number to whatever you want. Just remember that if your count goes above 255, the analog write will only write 255 because that's as high as it can go. And it can only go as low as 0. So let's modify our program in another way. Turn the stepping back to 1 in both loops. And then throw in this line just after the delay function in each loop. So now we are treating the count just like any other variable and performing some math on it. Now it could be very complex math or very simple math. I'll leave it up to you. All I did here was count up or down by 51 again. So every time it runs the for loop, it steps by 51 on the count. Flash your Arduino and you'll see it basically behaving the same way it was, but now it's doing it by a completely different method. Let's now take it a step further. If I get rid of this line by, say, commenting it out, it takes a step of 1 on the pulse width modulation every 500 milliseconds, half a second. So counting up every half second till we get to 255, will take about 2 minutes and 15 seconds. Now, this is a very slow and visible stepping that takes forever. So let's modify this line so that when we push our push button or connect a wire from input pin 2 to ground, only then does our count step by 51. So here you can see the action that takes place when I connect pin 2 low, influencing the stepping through the count in the for loop. Hopefully you grasp the power of these loops with these simple programming experiments.